Guys, I'm Mohammad Akif Chaman, and in this video I'm going to discuss about the problem called interesting XOR from the March long challenge of Codechef 2021. For those who haven't read the problem statement yet, I'm gonna quickly just review this. So the problem statement is as follows: you are given an integer c. Let d be the smallest integer such that 2 raised to the power d is strictly greater than c. Okay, this is a very important line of this statement. Okay, consider all pairs of non-negative integers a and b. A and b should be in pairs such that a and b both will be strictly less than 2 raised to the power d, and a XOR b will be equal to c. So you need to know what is the XOR operation and what it does. Find the maximum value of a into b over all these pairs. Okay, so the input format is the first line of the input contains a single integer t denoting the number of test cases. The description of t test cases follows. The first and only line of each test case contain a single integer c. Okay, so the constraints are a matter of concern here, so you need to be careful about the constraints. I'll tell you later why you need to be careful about these constraints. There are two subtasks. One is for 30 points and the other one is for 20 points. If you apply a naive approach, you will get at least 30 points. If you do this in my way, but if you follow the total instructions that I give you, then you will get this subtask 2 as well, so you will get the total 100 points. There are a few examples given. I will discuss this also. So yeah, I think the problem statement is clear for you guys. If it isn't, I'm gonna make it more clear here. So let's get into that. So this is our test case, actually the number of test cases, and this is our first test case 13. For 13 the output should be 70, and this is our second test case 10. For that the output should be 19. So before jump into the logic, I'm gonna tell you what things you need to actually learn, or you need to know before doing this very interesting problem. So first thing first, you need to know what is an XOR operation. Secondly, you need to know how to calculate, calculate a raised to power b using binary exponentiation. Okay, and thirdly, you need to know how to calculate log 2 base x. These are the three things you need to know to solve this problem. You can pause the video and take a note. Okay, so first we will discuss what is an XOR operation and how it actually works. So the every decimal number, when it goes to the computer, it converts into a binary sequence. Like if we give you a number 5, then it will be converted into 1, 0 and 1 in least digit. At least if it's 32 bits, then it will be having 29 zeros before it, then 101. Okay, this 1 represent 1, then this 2 and 4, but this 0, so 2 won't be count. 1 and 4 equals 5. That's how it goes. I hope you all know that, so I'm not gonna discuss this further. So this converts into this 5 converts into this binary sequence. And what if we give you a 7? Then it will convert into 111. Okay, so the XOR operation does like this. If we have a plus b, so the answer can be 0 or 1, either 0 or 1. So if a and b are not equal, I mean if a equals 0 and b equals 1, or a equals 1 and b equals 0, only then the output will be 1. If they're same type, like a0 b0, then the output will be 0. If a1 b1, then output will be 0 as well. Okay, this is how binary XOR operation actually goes. So for this 5 and 7, if we do XOR between these two, by the way, this is the sign of the XOR also given in the problem statement. So we can see this, for these two index we have similar bits, so both are 1, so we will get a 0 there. In the second one we get a 1 and a 0, so these are different, so we'll get a 1. And for this 1 and 1 we get again same bits, so we'll get a 0. So what is the result of this XOR operation? 5 and 7 XOR, what does it give? It gives us 2. Okay, it gives us 2. So the binary XOR of 5 and 7, we can write it like this, equals 2. Okay, so there is another interesting concept here. Like if we see as the arithmetic uh, addition, like if we add 5 and 7, it gives us 12, right? So if we add 12 with 7, do we get 5 back? No, we get 17. Again, if we add, sorry, it's not 17, it's 19. And if we add 12 with 5, do we get 7 back? If we add 12 and 5, do we get 7 back? No, we get 17. So like in arithmetic operation, if we add the 5 or 7 with the result, then we don't get the previous values actually. But in case of XOR, it's different. Like if 5 and 7 are getting XORed, then we get 2, right? This 0 1 0 represents 2. Okay, so if I do XOR between 7 and 2, we'll get 5. Let's see that. Here 7 equals 1 1 1 and 2 equals 0 1 0. If we do the XOR operation between these two, let's see, this 1 and 0 are different, so we'll get a 1. This 1 and 1 are the same type, so we'll get a 0. And this 1 and 0 are different, so we'll get a 1. And this is the binary representation of 5 actually, so we'll get 5 back. Okay, same thing goes for if we do the XOR between 2 and 5. Okay, like 0 1 0, we did it with 2 and 7 previously, now 2 and 5. Okay, so 5 gives us 1 0 1. So when we do the XOR between these two, we'll get 1 and 0 1, 1 and 0 1, 1 and 0 1, so 7. So we can see that with the resultant value, if we XOR this one or this one, if we XOR this with the resultant, we will get this. And if we XOR 7 with 2, we'll get 5. So this is very interesting, and this is we can call this like reverse XOR, you know, like getting the value that were previously here from the resultant. Okay, so this is a very interesting concept. We'll use this concept very much. And now I'm gonna discuss what is binary exponentiation. Not totally like there's a tons of video on binary exponentiation on YouTube. You can search that and learn from there. And if you want me to make a video on this, let me know in the comment section below. I'll try to make that later after this contest. And what it does actually, when we do like a raised to power b, if we use the power function of C++, and if like a and b are both like in this range, then we'll get a TLE. You know, it's if it's like 10 to the power 9, big range. For 0 it will work, or 0 to some like range 10 to the 6 or 10 to the 7 it might run, but for 10 to the 9 it might get us a TLE. So we can't use this power function of C++. So we need to know what is binary exponentiation, and how it helps in calculating 8 raised to the power b. So I leave it this to you guys. I hope you will learn it by yourself. And now uh, let me just clear this a little bit. So let's write the test cases again. For 10 it was 91, and for 13 it was 70. Okay. Now that we have already covered the what we need to learn first and what we need to learn second, the XOR and the pattern exponentiation, now we will gonna go and we are gonna see what is the third one, that was the log 2 base of x. Okay. There's a lot of videos on that as well. It's just a small snippet of code, and I hope you guys can find it out online. It's a very simple code, and if you don't understand that code, you can leave a comment in the comment section below, and I'll make a video on that describing how actually log 2 base of x works. Okay. So basically I'm gonna show how it really gives us output, but not gonna show you the actual code or procedure. So if I give you like 8, a value 8, and I say you what and I ask you actually what is the value of log 2 of 8, and what it will do actually, like 8 equals 2 base to the power 3, right? So we'll get the answer as 3 here actually. So the answer will be 3. Okay. If I give you 16, then it's actually 2 to the power 4, then the answer will be 4. Okay. But if I give you the 10, it will count like 2 to the power 3 points dot 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 something. Okay. So as it get typecasted, it will give us answer of 3 actually. Okay. So this is basically how it works. So, and this has also a very interesting concept in this problem. Like if we add log 2 base of 8, which gives us 3, and we if we see the binary representation of 8, like 1 2 4 8 here, like this. Okay. So we get, for 8 we get 1, then 0 for the others. So we see that we need 4 bits to represent 8, at least 4 bits. Okay. And if we say like log 2 base of 4, then we'll give like 2. Okay, so what is the minimum bit that we want to represent a 2? It will be like 1 2 4 and 8 will need at least 2 bits. Okay, so this thing has a significance. I'll tell you why in a couple of minutes. Just try to remember this. This value is important in the bit representation as well, like how many bit do we need. Like there here the answer is 3, but the bit we need is 4, so we need actually 3 plus 1 bit. So this is an important observation. Okay. So when we actually see here, what we actually see here is when we're given a 10. Okay, so we first do the third thing here. We'll make we'll count the value of log 2 base of 10, right? So we'll see like log 2 base of 10, it will give us a 3. Okay, it will give us a 3 because of the typecasting. It won't give us 3 point something, it will give us a integer value. Okay, so if we get a 3 bit, if we get 3 bits, what is the maximum value that we can achieve from 3 bits? If we make all of these ones and the values corresponding decimal values are like this, we get 7 from this bit sequence, but we have to get 10 at least, right? We have to get the 10 because we are giving input as 10. So for making 10, how many bits we need? Minimum how many bits we need? We need 4 bits actually. Okay, the 4 bits represent 1 2 4 and 8, total of 15. And if we want to create 10, the sequence will be like this: 1 0 1 0, it is 10. So for making 10 or for representing 10 as binary form, we need at least 4 bits, but the answer we are getting is 3. So we have to calculate the log value first, then add 1 with the result for to get the number of bits we require to represent a value here. Okay, so this is the main thing actually. Like when you say log 2 base of 8, it gives us 3, but when you see the this thing, if we get 3 bits, we can achieve maximum of 7. To get 8, we need 3 plus 1 equals 4 bits actually, like 1 1 1 0 0 0. This is 8, so we need 4 bits to represent 8. Okay, so this is a very nice observation that you need to make. Let me just rub these things a little bit. So we are almost done with this problem, just a little things left. Okay, so now that we know, what do we need to do first? We need to calculate the log 2 base of this value, and what we get, we need to add 1 to the answer. Okay, then there are a few interesting observations left that I'm gonna show you with a code, simple code. And this is the code of actually A XOR B, right? This is the XOR sign from the language. So if we run this code, and as we see, as I try to show you, like if I give 13 as the input, 13 and maybe 0 like this, we get a 13. Okay, so how does it really work? It works similarly as we showed in like binary form, right? Like for 13, how do we get it? Okay, like this and this is 13, and for 0 it's like this and this is 0. And when I do the XOR of this, we'll get 1 1 0 and a 1, so this is actually 13. Okay, so that's how it works. So when we do 13 and 1, this is how it goes. So the XOR value will be 1 1 0 and 0. This is gonna be 12. Okay, so we see if it works really. 13 and 1, yeah, the result is 12. Okay, so if we see 13 and 2, result will be 15, and I will keep this up. Okay, 13 and 3, the result will be 14. But we don't need to do it with 13 every time, you know. We'll do this like that. Okay, I'm gonna show you again. We'll first do with 13 and 0. Okay, then we'll make increase in the right one, like 0 will be 1 and 13 will be 12. So 12 and 1, which gives us 13, and then we again reduce the left one and increase the right one, it gives us a 9. So we'll reduce the left one and increase the right one, it gives us a 9. Then again left one will be reduced, right one will be increased, this, and we keep on going like that until the left one becomes 0. Okay, so have we done everything right here? 11 and 2, 10 and 3, 9 and 4, 8 and 5. Okay, I did some pretty bad mistakes here. From 6 I actually decreased the left one as well, so my mistake, sorry about this guys. So from 6, like 8 and 9 and 4, 8 and 5, 7 and 6 are not the right thing. 10 and 3, and will be 9 and 4, it will be 8 and 5, it will be 7 and 6, and it will be 6 and 7 actually, right? 6 and 7 gives us 1, and then 5 and 8 will gives us 13, and then 4 and 9 gives us 13, and 3 and 10 will gives us 9, 2 and 11 gives us 9, and 1 and 12 is 13. Okay, and 0 and 13 will gives us this. Okay, so what was our answer actually for like 13? What was our answer? Our answer was 7 into 10, right? I mean 70. So do we get any 7 into 10 here? Do we get any 7 into 10 here? No, we don't get any 7 or 10, you know. But if we like write, or if we see how can we get 13 like this gives us a 13. Sorry about that. 0 and 13 gives us 13, 1 and 12 gives us 13, and 4 and 9 gives us a 13, and 8 and 5 gives us the 13, 9 and 4 gives us a 13, and 12 and 1 gives us 13. And if we calculate the multiplication value of this, like we get, and 8 and 5 gives us 13, 4 and 9 gives us 13, 12 and 1 gives us 13, 13 and 0 gives us 13, and maybe that's the only things. So 40, 36, 12 and 0. So we get these values actually, right? But the answer is not 40 because there are maximum 40, right? What we get 13 for 13 is 70. So can we get 13 another way, in another way, like apart from this given way? Actually yes, we do. If we like write 7 and 10, we get a 30, right? So the multiplicative value of 7 and 10 is 70, and that's our answer actually, right? So but if we iterate, we don't get any 7 and 10, so we don't actually get 13 from there. So what we need to do, that's the main question here, and how we actually get that 7 and 10 in the easiest way using the previous approach that we used, like log 2 of something, right? So sorry, so when we show you that log 2 base of 10 will be 3, and we need to add 1, so it will become 4. So we need to calculate what is the value of 2 to the power 4. It will give us 16. Okay, this thing is actually gives us how many values, different values we can get from 0 until it gets 16. Okay, and not 16. So like we get 16 different values. Okay, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. There are 16 values, unique values. Actually this is represented by 2 to the power 4 actually. Okay, so how does it help us? Like, if we see, if we didn't add this one, we wouldn't get this 4, and as we have added this one, we get a 4 and we get 2 to the power 4, and that's why we get 16 values starting from 0 ending to 15, and 10 lies between this range here. Okay, so we need to do the maximum. We need to find the maximum here first. For 10 we have calculated that we need 4 bits at least, and with 4 bits we can make 15, maximum 15. Like, if we make all the bits 1, then we get 15. So we can achieve 15 with 4 bits, right? So we need to calculate that. But what we get from 2 to the power 4, we get a 16. Okay, we get a 16. So what we need to do is we need to actually actually I'm going to show you one more thing. Like, here we get 16, but our how did we get 70? Actually, by multiplying 7 and 10, right? And can you see any relationship between this 7 and this 16? I mean, how you can get 7 from this 16? Yes, you can subtract 2 and then divide this value by 2. Then we'll get 14 by 2. That will give us a 17. I mean 7. And this is the only thing you need to understand here. Okay. So first you need to calculate how many bits are there by using log 2 base of the given value. This is actually the C value. Then first you need to calculate log 2 base of C. Then you need to add 1 with that, and then you need to subtract 2 from the power of 2 to the power this log, and after that you need to divide the whole thing by 2. Okay, so that will give you the first value. Like, if we want to see the answer from 10, we actually want to see 7 into 13, which gives us 91. Sorry, maybe I was writing this 7 into 10 before. That was the answer for 13 actually, and for 10 it will be like this. If I have written wrong previously, I'm sorry for that. Okay, so for this actually we have gotten this 7 value, right, by using that thing that I showed you. This will give us like something like A. Okay, and now we need to remember what we learned first, the cross XOR thing, right? Like A XOR B. If it gives us C, then C XOR B will give us A, and C XOR A will give us B. So this is very important. Like, we have given C, now we have already calculated A, and C is obtained by A XOR B. So we don't know the value of B, we know the value of A, and we know the value of C. So how can we get B? Obviously C XOR A will give us B. Voila, this is the main concept. We get the maximum ingredients that we needed. We got A and we got B. Now what we need to do, we need to just print A into B. That will gives us the maximum value, and this is our code. I mean, this is our logic, you know. So I think I have been able to make you understand this, guys. It's been a very long video, but to make you guys totally understand this and totally understand the mathematical concept of this. I actually need to do that. I hope it helped you guys, and as I can show you, my solution got accepted totally. And I also submitted the college life for, but it somehow got wrong answer, but my space arrays got accepted, and I'll make a video on that as well. And as soon as I can make the college life 4 accepted, I'm gonna make another video on that as well, hopefully. So thank you for watching this video, guys. I hope it's been useful for you, and if you guys have any queries, any confusion about this very interesting XOR problem, then you can let me know in the comment section below, and I'll definitely try to help you guys. Okay, so I'm gonna make this video end here, and we'll see you in the next video.